Hello everyone, welcome back to Knowledge Bytes. In today's episode, we are going to explore one of the most important concepts behind the modern AI system, that is embeddings and vector representation. If you ever wonder how ChatGPT understands that car and automobiles means almost the same thing, or why AI can find the similar documents even when the exact words are different, this episode is for you. Let's get started. So let's begin with a simple question. How does ChatGPT knows that? Car means automobile, happy means joyful, doctor means physician. The words are different, right? The spellings are different, but yet AI understand they are closely related. How is that possible? The answer is embedding. Embeddings are allow AI to understand the meaning behind the words rather than it's simply matching text, right? So by the end of this episode, you will understand what embeddings are, why AI needs them, how text becomes vectors, what vectors dimensions means, and popular embedding models, and how embeddings are used in real-time, real-world AI applications, right? So these concepts are foundational for semantic search, retrieval-augmented generations, that is RAG, and AI assistants, and many AWS AI services. Let's first understand the problem. Humans naturally understand the language. When we hear the sentence, I love AWS, we immediately understand its meaning. Computers doesn't. A computer only understands the numbers. It cannot process words directly. Before AI can understand language, it must first convert text to a mathematical representation. That representation is exactly what embeddings are designed to do. So, what exactly is an embedding? An embedding is a numerical representation of text that captures its meaning. Think of a Google map. Every city has coordinated that tells us exactly where it is located, right? So similarly, every word or sentence or document can be represented as a coordinates in high dimension space. Instead of representing physical locations, these coordinates represents meaning. Words with similar meanings end up close together. Words with different meanings end up further apart, right? So now let's see how this works. Suppose we have the word dog. Instead of storing the word itself, the embedding model converts into a list of numbers. These numbers called vector. The same happens for the word cat. Notice that the vector look different, but they are mathematically close because everything are similar, right? So AI doesn't remember the word itself. It remembers the vector that represents the word meaning. Now you may be wondering, why do the vector contain so many numbers, right? So each number represents one dimension. Think of it like an address. A street address tells us where a house is located, right? Similarly, vector dimensions tells AI where a word is located inside the semantic space. Embedding models may generate the vectors with a 128 or 384 or 678 or 2014 or even 1536 dimensions. In general, more dimensions allow the models to capture a richer semantic information and more subtle relationships. So now let's understand this. Imagine a Gantt three-dimension map. Words are represented as a point, right? So dog, cat, and wolf appears close together because they belongs to the same concept, right? Or else car, bus, and train, and another cluster, right? So the same way the apple, banana, or orange creates another group. So it's a cluster. Right, it's the same meaning. So this is because AI organizes the information based on the meaning, not based on the spelling or based on the words, right? That's why the semantic search works so well. Now understand the embedding models. So who creates these vectors? Embedding models, right? So these are the specialized AI models trained to convert text into meaningful numerical representations. Some popular examples includes, right? So Amazon Titan embeddings, or Open AI embeddings, or Cohere embedded, or BGE models, or sentence transformers, right? Although these models are different in architecture and dimensions, they all have the same goal: convert text into vectors that represents meaning, right? So now let's understand the AWS Service Mapping, how it is. Let's connect with this concept to the AWS. Suppose you want to build an intelligence document search application. First, your documents are stored in a Amazon S3. And next, Amazon Bedrock generates embeddings using a embedding models such as Titan embeddings, or right. So these vectors are stored inside the vector database like Amazon Operation Search, Open Search services, right? When a user asks a question, a query is converted into another embeddings. The vector database searches for the most similar vectors. Finally, Amazon Bedrock uses those retrieved documents to generate the accurate answers. So this is one of the most common architecture used in the Retrieval-Augmented Generation, that is called RAG. We are going to learn in upcoming videos, right? So let's understand the real world example. Embeddings are used almost everywhere in modern AI. Semantic search, right? So where results are based on meaning instead of exact words, or chatbots in so that understand different way of asking the same question, or in recommendation systems that suggest similar products or movies or book or different products or different the like videos, right? So machine translation that represents meaning across languages, or document classification where AI automatically categorizes the content, and even fraud detection services where unusual patterns are identified using the embedding similarity, right? So wherever our AI understanding meaning instead of the exact words, the embeddings are usually involved. So let's look at a simple example, right? Suppose someone searching for a word vehicle. The database may return car, truck, SUV, or automobile, right? So even if the exact words vehicle never appears, why? Because these embeddings are located close together. This search is based on semantic similarity, the keyword matching, right? Now, so not keyword matching, right? This is what makes AI search much smarter than traditional search engines. So let's understand the AWS AI Practitioner Exam Kernel, right? Now it's time to understand the knowledge with this topic, right? So the question is, so now what is the primarily purpose of embeddings? The answer A, compress images, or B is convert text into the meaningful numerical vectors, or C, encrypt data, or D is store files. If you look at that, B and C are very close. Do not confuse, right? So the answer is B. Embeddings convert text into numerical vectors that captures semantic meanings, allow AI to perform similar searches or recommendations or classifications and many other intelligence tasks, right? So same way. So today, let's quickly summarize today's lesson. Embeddings converts text into numerical vectors. These vectors capture meaning rather than the exact words. Similar meanings produce similar vectors. Embedding models generate these representations. Embeddings power semantic search or recommendation systems or chatbots or RAG, many AWS AI services. Understanding the embedding is an essential step towards mastering generative AI. So in our next episode, we explore the vector search and similarity search. So you will learn how vector database finds a closest embeddings, how similarity is measured, and how this technology powered intelligent search systems used in the modern AI applications. If you found this video helpful, don't forget to like, share, and subscribe to Knowledge Bytes. Thank you. See you in next episode.